Hey, and good afternoon, everyone. Meteorologist Thomas Patrick here, back with another edition of Weather Classroom live on Facebook. Thanks so much for being here, and thanks for putting up with a week off last week. Had some stray technical difficulties that kept us offline for a week's time, but we're back this week. Everything's running smoothly, and we're actually just going to go right into the topic that I was going to share with you last week, but do it here today, and that is on air masses. And this is something that can apply for a whole bunch of pretty much the entire US, anywhere in the world, to be honest. But I'm going to break down what air masses are classified as and how it affects our weather patterns across different parts of the United States, particularly when it comes to the winter time. And I'll use Spokane as my comparison because, of course, we're located here in Spokane, but I'm going to compare that to other parts of the northern US because as we now enter February, the final month of meteorological winter, take it from this guy growing up in Wisconsin and in the Midwest, and I just remember the winters being so cold growing up every single year. In fact, once it snowed in December, that snow pretty much stayed on the ground all winter long. Since moving out here in Spokane, and it's been 2 years and a couple months already, and the winters honestly not as bad as they are in Wisconsin, despite us being located farther north latitude wise. So I kind of went in depth and explained why Spokane winters, they're cold, but they're not as cold as other parts of the US. And I'm going to use air masses to explain exactly why that is. Of course, if this is your first time hanging out here in Weather Classroom, do make sure to hit the like button on this video as well as on my page at Meteorologist Thomas Patrick. You can also follow me on Twitter at Thomas Patrick WX there as well. And if you have any questions, do make sure to leave them in the comments below. I'll try to answer any of them live here on Facebook. So let's jump into things. And first of all, let's categorize what air masses are. And I can basically bracket it down into four different air masses, and we're going to break it down by if they are cold or warm, that's pretty simple, as well as wet or dry. And we basically just make this grid and we end up with these four different air masses. Maritime and continental divide the wet and dry air masses, and polar and tropical divide the cold and warm air masses. So that's the verbiage that goes with these different crosshairs. So maritime polar is a cold and wet or moist air mass, whereas a continental tropical would be a dry and warm air mass, or hot if it's the summertime as well. So we have these four different air masses are at play: warm and cold, wet and dry. Now let's take a look at North America, because it is all four of these air masses do influence the weather across the country. If you start on the polar side, the northern side here, you can tell that the maritime polar, the more humid air masses, come from the North Pacific or the North Atlantic, whereas the continental polar comes over the continent, or northern Canada, and in some cases the Arctic as well. And then on the other side, same deal. If those air masses originate over the ocean waters or the Gulf of Mexico, they have a maritime quality to them. But that desert air, like that dry heat that you would describe the Arizona summers as, that is a continental tropical air mass. So tropical doesn't always mean humid. Tropical just means it's going to be warm. Now, how are these different from one another? I mean, we can pretty much say that, okay, dry and humid have different qualities, but how does that affect the temperatures? Well, it comes down to a very simple example, and I have this by having two different water bottles here. I'll make it so that they are easily clear. Now, this is just room temperature air. Actually, there's nothing in this bottle at all. And then there's water in this one. I'm not going to turn it upside down, otherwise I'm going to spill all over myself. Now, if I had the same mass, and obviously that's not true in this example because this is heavier because it has water in it, but if I had the same amount of mass as air as I did water, and say I put these two bottles in my freezer or refrigerator, the dry one, the one without any water in it, even if it was the same mass of air, actually would cool down faster than the one with water, because water has a very unique quality to it. It has a very high what's called specific heat value. So in order to warm up or cool down, this room temperature water actually takes more heat to make that done. So I have to add more heat to warm up the water than I do the air itself because of its high specific heat value. So that in itself makes humid air masses, which have more water content to them, have more inertia, and the drier air masses are more susceptible to temperature extremes, and that goes both ways on the scale. So let's look at the polar air masses, because this goes along with the winter time. And actually, it was a previous weather classroom that I explained why the weather moves from west to east, and it's because of the jet streams. You can see that video kind of in the replay section on YouTube or Facebook right here. So the maritime polar air mass out of the North Pacific tends to draw eastward into the Pacific Northwest, into Spokane, whereas the continental polar air masses go towards the northern plains and the Midwest, like where I grew up in Wisconsin. And this basically means the continental air masses are colder than the maritime air masses are. And that's just because humid air masses have more inertia. Continental air masses are more viable to temperature extremes. Doesn't always happen that way. Sometimes that continental polar air can move into Spokane in the inland Northwest, and you'll see how that affects like our record temperatures. But here's the average low temperature at the end of January, when I actually made this graphic a week ago. The average low temperature in Spokane, 26 degrees. Compare that to a city like Bismarck, North Dakota, which has an average low temperature of 3 degrees, 23 degrees colder on average. That's not like a record. That's not like every once in a while. That is every single day, averaging 23 degrees colder at night. And it's because that continental air is more viable and more susceptible to those temperature extremes. Kind of the same deal when it comes to records, but notice how much colder our records are in Spokane. Basically, this is when the continental polar air, if it just goes its normal way towards the northern plains, or if it actually retrogrades back westward towards Washington and Idaho. Our records, in this case, I believe I took the record from January 26th, if I remember correctly. The record low about minus 17 degrees versus Bismarck, which is nearly minus 40 degrees. That's a huge temperature difference. And again, it's all because that air mass is so susceptible to those temperature extremes. It doesn't happen in the maritime instances. And it works the other way around too. In the summertime, when we have the tropical air masses, it is the continental air masses that give us those high temperature extremes, not the more humid ones. So here is, and I know this is where things might look a little bit complicated for our region. Here's a graph of Spokane's record high, average low, record low through the month of January. So that yellow bar in the middle is the average, and then the top, the red, those are the record highs per day, and then the bottom, the blue, is the record lows per day. And notice how there's a much bigger gap from the average low to the record low temperature in January. In fact, those are usually temperatures 30 to 50 degrees below average, or about 40 degrees colder on average would be record low temperatures. Compare that to the highs, where that's a much more narrow path because we don't really get continental tropical air even in the winter time. It's just too far away, only about 20 degrees above average. So that's a big disparity in terms of how the records play out in Spokane during the winter time. That continental polar air plays such a huge factor in our cold snaps and those record cold days, and it is something that we haven't seen a whole lot of this year. In fact, Rory said, did La Nina not pan out? Not really on the temperature aspect, because this winter has been a pretty mild one. We've had our fair share of snow. We're actually at average in terms of snowfall so far this year, but temperature wise, it looks like La Nina totally busted out, except that we still have the rest of this month to go, and it's going to get colder next week. So that's a little preview of the forecast later on tonight. But yeah, it takes that continental polar air, those Arctic blasts, that give us these really cold snaps. But we've been pretty even keel with that maritime polar air, which comes out of the North Pacific. That's been pretty consistent. That hasn't changed. That's not unusual for the wintertime, La Nina or not. We just get that. So our temperature differences usually don't stray too far from their normal. It's when that continental polar air comes backwards that can really push our temperatures down. And that's just a case that we haven't seen so far. Still have all February, so all March to go. But so far, it hasn't happened just yet. All right, so to recap our weather classroom, we have 4 different types of air masses split by cold and warm, which is polar and tropical, as well as humid and dry, which is maritime and continental. I had to do it without the graph. So we have those. And then our record lows are obviously drastically influenced by polar air masses during the winter time. And the same is true in the summertime, is it's the continental air mass, tropical continental, that gives us those hot days, those hot and dry days. That's how air masses pan out across the, not just the inland Northwest, but the entire U.S. I'll show that map one more time, because I just think it's so cool that all these 4 air masses pretty much just hug the U.S., and we're kind of the battleground in the mid-latitudes, and that's where our frontal systems come from, dividing, the cold fronts and the warm fronts, dividing those different air masses, give us all of our different weather aspects, and then you're just opening the Pandora's box into all the different weather topics. But that's it. So hopefully you found that very interesting, and why Spokane winters, take it from the guy that grew up in the Midwest, honestly aren't as cold as what they could be. For some of us, yeah, it's still plenty cold. We still have to layer up. We are still pretty far north, but we don't get that constant continental polar air mass as, say, my family does over in Wisconsin, and they got like a foot of snow on the ground right now. So take it from me, it could be worse. It's cold, but it could be a lot worse in the winter time. And honestly, our summers are fantastic because we get some dry summers around here. But we'll save that topic for a different day. And again, if you want to watch any previous Weather Classroom topics, you can find them right here on Facebook. I also do them live, mostly every Thursday at 1 p.m. Pacific time. You can also find them on replay on YouTube as well, and that's the Creme 2 News YouTube page. So thanks again, everybody, for tuning in. Please make sure to hit the like button both on this video and on the on my page and on the Creme 2 YouTube page as well, so you can follow along, give live updates on Weather Classroom or on any kind of crazy weather that might be happening in the Spokane area. We'll do live videos for that too. So that's all from me today. Thanks again for joining us. Have a great rest of your day. Enjoy this weekend. Enjoy the Super Bowl if you're going to be watching that too, which of course is going to be on our network as well. So thanks again. We'll see you next time on another edition of Weather Classroom. Take care, everybody. We'll see you.